Let's look at the question, rotate array. We are given an array, names, and we need to rotate this array to the right by k steps. Well, k is a non-negative number. The first example, we input names is 1, 2, 3, 4, 5, 6, 7, and k is 3. So we rotate it 3 steps to the right. So we will get 5, 6, 7, 1, 2, 3, 4. And the second example, we input names is -1, -100, 3, and 99, and k is 2. So we rotate it 2 steps to the right, which will get 2, 99, -1, and -100. So the easiest solution, we will use the additional memory to hold the value, and that is perfectly fine. So let's try an approach that using extra array. The algorithm is we using an extra array in which we place every element of the original array at its correct position. For example, the number at the index I is in the original array, right? Now is in place at index at I plus k multiplied by the length of the array. I plus k means I is the original index and k is how much we shift, and multiplied by n is the length of the array. So if we have 7 elements, we rotate it 8 times. So we only need to rotate 1 time instead of 8 times, right? To speed up the rotate speed. Then we copy the new array to the original one. We are done. Let's try to build the algorithm in Python. First, we set n is the length of the names. And then we set a extra space. We initialize every element to 0 and multiply by n. So n is how many elements in the original array. We just create the same size in the new array to hold element for it. And we'll have only one for loop for I in range n. So I loop in the n every time. We just shift every element I original position plus k. K is how many we need to shift, but before do that we need to multiply by n. So you get the value from names at I. Then after we do that, we just assign the new arrays element one by one to the original one. Yeah, that is how it works. So let's analyze the complexity. The time complexity is all fun because only one pass is used. We just put the numbers into the new array, and the other pass is to copy the new array to the original one. And about the space complexity is just all of n because another array of the same size is used. We have a given array and we need to rotate this element to the right, rotate it k times. So the question asks us, could you do it in place with all of one extra space? Yes, we can. When I'm trying to solve this problem, the actual trick comes to my mind without using any additional memory is that we need to use original array somehow to move the elements around. Now we can place each element in the original location and shift all the elements around it. So this is the first approach, brute force. It is the simplest approach. We just rotate all the elements of the array in k steps by rotating the elements by 1 unit in each step. So let's try to build the algorithm in Python. First, we notice we have a k for how many times we rotate. We modulate by the length of the lambs. So if it is very big, like if we have k is 8, we have to rotate 8 times, but if we rotate 8 times, we have only 7 elements here, we will get the same result as rotate just 1 time. So this modular will make it more quick, rotate more quick. Then we can start for I in range, like k. I is for tracking for how many times we rotate. We set a previous variable to hold the last element, like lambs at -1, which is the 7 in the first time. It always take the last element for exchange. And we set for j in range is in the range of lengths of the names, and we just exchange the value here. The lambs at j exchange the value with the previous. So the previous and the names at j. So yeah, that is how it works. Let's analyze the complexity. The time complexity is O of n multiplied k because all the elements are shifted 1 step. they have all of n steps and multiplied by k rounds. So this adjusts as it would be too costly. When the input is too large input, most likely it will time out. And the space complexity is all of 1 because there's no extra space is used. The third approach is using cyclic replacement. The algorithm is we can directly place every number of the array as its required correct position. But if we do that, we will destroy the original element. Thus, we need to store the number be replaced in a temporary variable. Then, we can place the replaced number in this temporary variable as its correct position, and so on. We will operate n times. Well, n is the length of the array. We have chosen n to be the number of replacements since we have to shift all of the elements of the array n times. So the time complexity is O of n because we only use one pass, right? But there could be a problem with this method. If n measured by k is 0, so n is the multiple and n divided by k exactly without any remainder. When a value of k is larger than n, eventually it will lead to k equivalent to k multiplied by n. So in this case, well, we have to pick in the numbers to be placed at the correct position. We will eventually reach the number from where we originally started. Thus, in such a case, when we hit the original number's index again, we just started the same process with the numbers, so we just follow in the process. Now let's look at the proof of how the above method works. Suppose we have n as the number of elements in the array and k is the number of how many shifts we have to require. So further, we can assume n multiplied by k is 0. Now we start placing the element at the correct position. In the first cycle, all the numbers with the index I satisfying I multiplied by k is 0. Then they get placed at the required position. This happens because when we jump k steps every time, we only hit the numbers k steps apart. We start with index I is 0 and we having I multiplied by k is 0. Thus, we hit all the numbers satisfying the above condition in the first cycle. When we reach back to the original index, we have placed n divided by k elements at the correct position, right? Since we hit only that many elements in the first cycle, now for replacing the numbers, we just increment the index. This time, we place another n divided by k elements at the correct position, which is different from ones placed correctly in the first cycle, right? Because this time, we hit all the numbers satisfying the condition. I multiplied by k is 1. We hit the starting number again. We increment the index and repeat the same process from I is 1 for all the indices satisfying I multiplied by k is 1. This happened till we reach the number with the index, that is I multiplied by k is 0 again, which occurs for I is k. We will reach such a number after a total of k cycle. Now, the total count of number exclusive numbers, is placed at the correct position, which will be k multiplied by n divided by k, which is also n. Thus, all the number will be placed at the correct position. So let's start turn our algorithm in Python. First, we said n is the length of the lambs, and then we have a k. We should multiply by n. So if it is bigger than n, then we just take the remainder, we just shift remainder times, right? And then we have start. Start is to record how many cycles inside it, and count is count to count how many times we shift the number, how many times we replace the element, right? So it is less than the 6, but first we initialize to 0, and then we said while the count is always less than n. So in this time we have 6 elements, so the count is maximum is only 5, because if we move 6 times, we will shift to the original location. So the maximum is 5, right? So we can set a current is pointed at the current and the previous. So the current is start is equal to start in the first time. So in this time start is 0, but in next loop the current is 1 it will shift, and the first time is start from the first element inside it. And then we can start in the inside loop while true. We set a next pointer, which is the current plus k. So current is pointing at the current element, and plus k is how much we want to shift, and then we multiply by n. So if it is a move too much, to move to the right, shift to the right, shift to the right, until it's too much, until it's bigger than n, so we just put it to the back, multiply by n, so it will only take the from the beginning and plus the remainder, right? And then we exchange the value with the lambs pointer at next, exchange the value with the previous, and the previous exchange the value with lambs at next, and then the current will record the next, because the next time the next will move to plus k, so we just use the current to remainder, so the current plus k and shift back and to do it again. And count is count how many times we place the number, we exchange the number. So every time after we exchange the element, we will increment by 1 to record it. So if we shift many times, we will maybe, because it will multiply by, maybe it will back to the beginning. If it back to the beginning, the start is equal to curve, then we just break. We just finish our cycle. So outside it, we just use the start to shift one little bit to the right. So make sure they will not the same. We will not fall into the dead endless cycle, right? So that is how it works. Yeah. In the fourth approach, let's try to use in reverse. This approach is based on the fact that when we rotate the array k times, k elements from the back end of the array come to the front, and the rest of elements from the front shift backwards. So in this approach, we firstly reverse all of the elements of the array. They are the elements from index 0 to n-1. Then we reverse in the first k elements. They are the elements from index 0 to k-1, followed by reversing the rest of n-k elements. They are the elements from index k to index n-1. So after we call these functions 3 times, this is a reverse function. It gives us a required result. We required it. So let's analyze its complexity. The time complexity is O of n. Well, there's n elements are reversed, and we multiply a total of 3 times, so which is O of n multiply k times. And the space complexity is just O of 1 because there's no extra space is used. Now let's try to build algorithm in Python. First, we need to define the reverse, which is the function we need to use. They have a self, and the names is a list, input list, and the start is a pointer with the start number we want to exchange, and the end is the end pointer at the end number we want to exchange, and then we return none. So that means we only change the elements in the names. Then while the start is always less than end, it will work, and the names at start and the names at end, they will exchange names at end and names at start, and then the start and end will change every time. The start will move to the right, increment by 1. The end will increment by 1, move to the left, and then we are done. So it will increment by 1, decrement by 1, and run again until the start is equal or greater than end, and then we can run it and define our main function is rotate. It have self parameter nonce. They have names integer element, and k is a integer, right? How many times we shift in k, and return none. and n is the length of the names, and k modular by n, which will get the reminder to shift. And then we just run this function 3 times, self.reverse. The first element is names, and start with 0, and with last element n minus 1, and then we do it 3 times, 1, 2, 3, and then the second is from 0 to k minus 1, the first k, and then the last is k to n minus 1. So there are 3 times. So let's run.